Hello. Can anyone confirm? Am I audible? And my screen is
Yes, sir.
visible? My screen is visible to
Yes,
you?
sir. Yes, sir.
Okay. Thank you. Okay. Good evening, everyone. My name is Chandan Kumar Gupta. I am a Prime Minister Research Fellow in Department of Mathematics, IIT Patna. I am your NPTEL TA for the course Introduction to Probability Theory and Statistics. This course is offered by Professor S. Dharmaraja. He is currently a faculty in IIT Delhi. This is the ninth week of a 12-week course. Uh, Up to week 8, we have discussed about the probability theory. Okay. Now, from week 9 onward, we will discuss about the statistics, in which we have discussed about lots of things. Okay. So just take a recap about what we have completed till now and what we are going to complete in the next 4 weeks. Okay. So in probability theory, okay, we have discussed about like basics of probability, okay, in which we have discussed about different random experiments, sample space, axiomatic definitions of probability, conditional probability, and total law of probability, multiplication rule, and Bayes theorem, etc. And we have also discussed about the random variables, in which we have discussed about different kinds of random variables, definition, cumulative distribution function, discrete and continuous random variable, a mixed type of random variable, and etc. And then we will discuss about moments and moments inequalities, in which we have discussed about the first and second order moments like mean and variance, higher order moments, moments inequalities like Chebyshev's inequalities, Markov inequalities, Jensen inequalities, etc. And then we have also discussed about generating functions like moment generating function, characteristics function, probability generating function, and etc. Okay, then we have discussed about different discrete and continuous random variables that are standard type of random variables. Sorry, standard distributions actually. That is like Poisson distribution, Bernoulli distribution, binomial distribution, negative binomial, geometric, and then the continuous type of distribution as well, like normal, exponential, gamma, beta, Weibull, etc. Okay, and then we have also discussed about like higher dimensional distribution, we have discussed about bivariate distribution when we are dealing with like two random variables simultaneously. We have also discussed about the logic of multivariate distributions, then the joint PDF, how to calculate the marginal PDF with the help of those joint PDF. When we say that the two or more than two random variables are independent random variables, these we have discussed in the 5th week of the course. Then we have discussed about the ordered statistics, conditional distribution, random sum, that is comes under the functions of several random variables. Okay. And then we have discussed in the 7th week about cross moments, in which we have discussed about again variance covariance matrix, how to define covariance, correlation and regression, conditional expectation, conditional variance. These are these have been like discussed in the 7th week of the course. And in the last week, we have discussed about the limiting distribution. Okay, in which we have discussed about like modes of convergence, in which we have discussed about different kinds of modes of convergence, like convergence in probability, convergence in distribution, convergence almost surely. So also we have discussed about law of large numbers, like Bernoulli's law of large number, weak law of large number, and strong law of large number. And at last, we have discussed about the central limit theorem. Okay, so these are those topics that we have already covered up to the week 8, which is comes under the probability theory. Okay, now we are in week 9, in which we have discussed about the statistics part. Okay, the introduction to statistics. That like in statistics, we are mainly going to discuss about like descriptive statistics, descriptive statistics, and then we have also discussed about like point and interval estimations, then testing of hypothesis, and at last in the 12th week we have discussed about the analysis of covariance and regression that we will discuss in the further weeks. Now in this week we are going to discuss about descriptive statistics and sampling distribution. Although it is quite large topic, but we just touch the like concepts related to these topics and solve some numericals based on these topics. Okay, so like in descriptive statistics, we are mainly discussing like we are going to discuss about different kinds of data, frequency tables, graphical presentations of data, central tendencies, okay, variability measures, skewness coefficients, and kurtosis. These we are discussing statistics, descriptive statistics part. And in sampling distribution part, we will discuss about mainly three distributions that are chi-square distribution, students t distribution, and f distribution, and some properties related to these distributions. Okay, so let's start the week 12 lecture. The first is descriptive statistics. So we are mainly like discuss these statistics in four parts. The first one is measure of central tendency. The second is measure of dispersion. The third one is measure of skewness. And the last one is measure of kurtosis. Okay, these are the mainly four things we need to know about any kind of data so that we have some descriptions about those data. Okay, those description like can be defined on the basis of these four measures. Okay, so let's start one by one. The first one is measure of central tendency. Okay, so okay, so in measure of central tendency, like we choose those values, okay, that is like represent the whole data. Okay, that represents the whole data that are called the data is centrally tended to that particular value. So that is called measure of central tendency. There are different kinds of measure of central tendency like mean, median, mod. There are also like geometric mean, like harmonic mean, and some other statistical measures are also there. Okay, so we are mainly going to discuss about like mean, median, and mod. Okay, so let's start with mean. Okay, everyone know about the mean. Mean is also known as like average value. Okay, or average. We have also like use expected value or expectation of x. Okay, Expectations are also nothing but the mean value. Okay, average, mean value, these are the mean. So we have different kinds of formula for different kinds of nature of data. Like suppose we have different data like x1, x2, and so on, x and random samples are there. Then we have different form of formulas for mean. Like the first one is like direct method, in which like we can directly calculate the mean. That is also like denoted with the x bar, and that is nothing but sum of observation upon number of observation. Okay, so that is like summation over xi divided by n. Okay, these are the direct method that we have already used. This is nothing but the average method. Okay, suppose we have frequency distribution. That means we have the observation value, and with the like together with we have the frequency, that how many times that particular observation occurs. Okay, so in that case, suppose x1 number is occurs f1 time. Okay, x2 observation occurs f2 time, and similarly xn observation occurs fn time. So in that case, the mean value can be calculated as like this: summation over fi xi, I from 1 to n, and divided by summation of fi. We can sometime use summation of fi equal to nothing but capital N for the ease purpose. Okay, so this is one of the simplest formula to calculate the measure of central tendency or mean. Okay, sum of observation divided by number of observation. The same can be written as the summation of fi xi divided by summation fi when we are given a frequency distribution. Okay, we also, there are one more case when we have a grouped frequency distribution, like we have a class interval. Suppose we have a class interval like 0 to 10, 10 to 20, 20 to 30, and so on. And we have frequency. So in that case, suppose F1, F2, F3, and so on. And then we will calculate the mean. Okay. Uh, in that case, we just define one class mark. Okay, class mark, which is also denoted as xi, which is nothing but the mean value or the mid value of those class interval. Here 0 to 10 hai, that means it is 5, 10 to 20, that means it is 15, 20 to 30, that means 25, and so on. Then the same formula, the direct formula, can be used. Okay, again, since sometimes we deal with a larger set of data or a higher digit of data. Okay, big numbers we are going to deal. In that case, it is like not possible to calculate the summation of fi xi or summation fi. It is not feasible actually. It is possible, but it is not feasible. Okay, so in that case, we just scale down those data so that our calculations are simplified. Okay, so in that case, we use assumed mean method. Okay, so these are nothing but the same formula, just a transformed version, or that we will use when we are going to deal with different larger or bigger data. Okay, so assume mean method, in that case we assume one mean value. Suppose in that case we assume this is the nothing but a, so that means the 15, the value of a is nothing but 15. Okay, so in that case a plus summation fi, and it's nothing but di, and divided by summation fi. Okay, so here it is di is xi minus a. Okay, so in that case we just uh, subtract a value, the assumed mean value, from all the class mark value or xi's, And at last, we use this formula, the star expression, to calculate the assumed mean method. This gives the same result as we have we will get with the help of the direct method. One more formula is there. Okay, one more simplified version or less calculative one is like step deviation method is there. This is also used to calculate the uh, mean value. Again, mean is defined as like assumed value A plus its summation of Fi. It's nothing but Xi minus A upon H. Okay, divided by summation of Fi. I is taken the range from 1 to n into H. Okay, so this is assumed mean method. Here xi minus a upon h, this is also like sometime we, okay, let me write it in a simpler format. Okay, so sometime we will also write it fi ui. So here ui is nothing but xi minus a upon h. Okay, so it makes the data more like simpler format so that we are able to calculate the mean value by hand or manually as well. Okay. So this is the formula we are going to use to calculate the mean value. In a similar manner, median is also there. Okay. So median is median like the value of observation that divide the whole data into two equal parts. The value of observations which divide the whole data into two equal parts. Okay, so that observation value is known as the median value. Okay, that is the mid value that divides the whole data into two equal parts. Okay, these are also termed as like positional average. Okay, these are also termed as positional average. That means it divides the data into whole part on the basis of their positions. Okay, so there are different kinds of formulas to calculate different types of data. Like when we are discrete data, 1, 5, 7, 9, 11, something kind of data, then we can calculate the median value. Suppose there are some cases actually. Suppose we have a discrete data and the number of data is like odd. So in that case, the median can be calculated as like n plus 1 by 2th observation. And how this observation like we will get this observation when we have data, then we first arrange these data in in increasing order, and then we find out the n plus 1 by 2th observation, and that n plus 1 by 2th observation is the mid value of those data. Suppose we have 5 data, in that case n plus 1 by 2th is 3. So that is third observation is the our median value. Okay, so this is how we calculate the median when we have like even number of data, when n is even. So in that case, the median is defined as the mean of the two mid values. That is mean of the two values, n by 2th observation plus n by 2 plus 1th observation. And then these two values are added, like we add these two values, and then taking the mean value of these two observation gives us nothing but median. Okay, these are the formula we will use when we have a discrete type of data. Okay, but what if we have a group frequency? If we have group frequency data. Okay. So in that case, the median will be calculated as, okay, let me just, like we have a class interval, like 0 to 10, 10 to 20, 20 to 30. We have frequencies like F1, F2, F3. We have cumulative frequency actually. Okay, that is like F1, F1 plus F2, F1 plus F2 plus F3, and so on. So this is how the group frequency distribution data looks like. Okay, so in that case, like we need to calculate the median, which is defined as like L plus n by 2 minus C upon F into H. Okay, this is the formula. Now, how to find out these different variables like L and n by 2 is nothing but like the total number of frequency available and then by 2, and C and F. So here like L is the lower limit of median class. Okay, C is like cumulative frequency of class just preceding the median class, and F is like frequency of median class, and H is width of the median class. Okay, so this is how. Now the question is how to find out the median class. The median class is find out with the help of the total frequency. Okay, here the total frequency is summation Fi. Okay, summation Fi is the total frequency that can also be like denoted with capital N. Then since we are going to find the median, okay, that means the half, okay, the mid value. So we divide the N with the by 2. Okay, and then we check the N by 2 value. Suppose it comes out to be 25 for an example. Okay, so then we are going to in the cumulative frequency column, and then we check the value of the cumulative frequency that is just above the 25. Okay, so those class that having the cumulative frequency just above the 25 is our median class. Okay, and then we have all the information like how to find out L, n by 2 is there, C, F, and H. Then we are able to calculate the median value of that grouped frequency distribution. Okay, also like we have different kinds of positional average, not only the median. Median is like those observations that divide the whole data into two equal parts. Okay, in a similar manner, like we are able to calculate the decile. Okay, 10 equal parts. That means uh, those 9 points that divide the whole observation or whole data into 10 equal parts are called deciles. Okay, we have also percentiles. Similar again, we have 100 equal parts are there. Okay, so that means we have 99 points. We have 99 observation points that divide the whole data set into 100 equal parts are called percentile. We have like quartiles. Quartiles are there. That means we have 3 points that divide the whole observation into 4 equal parts. Okay, so there are lots of positional averages there like percentile, quantile, octile, decile. Okay, so these are nothing but the average in a positional way. So it is called positional average. Okay, and everything can be like for decile purpose, we divide n by 10 and the similar median formula is used. Just we put the value I. IN divided by, if we are going to calculate decile, divided by 10, if we are going to calculate percentile, divided by 100 is there, and so on. Okay, just a simple logics. Okay, so these are the median. We have also calculated mod value. Okay, we are like able to calculate the mod for the given data set. Mod is defined as the most frequent observation. Can anyone confirm I am audible, na?
Yes, sir.
And the screen is visible, na?
Yeah.
Thank you. Okay, then mod is like most frequent observation. Those like that observation which is like most time occurred in the data set. That is mod. This definition fits for when we are dealing with the discrete data. Okay, when we are like group frequency data, then in that case the formula for mod or is like again L plus f1 minus f naught upon twice of f1 minus f naught minus f2 into h. Here L, f1, f naught and f2 and h are defined on the basis of the model class. In the median, we define those parameters with the help of the median class, but in mod, we first find the model class. And the model class is that class which have the highest frequency in the group frequency distribution. Okay, so we have like class intervals and corresponding their class, different class intervals, we have their frequency. And that frequency which is maximum in all the like class intervals, that class interval is called the model class. And then from those, we are like able to find the L, which is the lower limit of the model class. And like F naught, F1 and F2 is there. Okay. So F1 is the frequency of the model class. Okay. F naught is the frequency just preceding the model class. Okay. Frequency of the class just preceding the model class. And again, F2 is the frequency of the class just succeeding the model class. And H is nothing but width of the model class. Once we are able to like find observe the model class, then we are able to calculate the mod value for that grouped frequency distribution. Okay. Also, we have actually one empirical relationship, just an empirical relationship. Okay. We can use it as in remark as well. There is an empirical relationship between mean, median, and mod. Okay, like this is nothing but 3 median equal to 2 mean plus 1 times of mod. Okay, this empirical relation is used when the data is slightly skewed, not highly skewed. Okay, when the data is slightly skewed, then in that case, we are able to use this empirical relationship to find the either mean, median, or mod when the two others has been calculated, will be calculated. Okay, when we are able to calculate the two of these three, then the third one will be calculated with the help of this relationship. But there are slight difference, but still we can use this relationship when we are dealing with a slightly skewed data set. Okay. And what is the meaning of slightly skewed, that we will discuss in the further slides. Okay. Now, up to this point, we have discussed about the measure of central tendency, how the mean value, the median value, and the mod value is calculated with the help of the either discrete or group frequency data. Okay. Now the next is measure of dispersion. If anyone have any doubt, they can directly ask. Okay. Measure of dispersion like scatteredness. Okay. It measures the scatteredness of the data, like measures the scatteredness of data. Okay, the data that we are like using, uh, that data, how the data is scattered. Okay, then there are different kinds of measures to measure the dispersion of the data set. Like we have range, uh, we have variance, we have standard deviation, we have coefficient of variance, and so on. Like mean deviation about some particular point, mean deviation about median, mean deviation about mean. There are lots of measures. Okay, so like range is defined as nothing but the suppose we have a random sample like x1 x2 xn, then from those random set or random data, the maximum value and the minimum value is there. Okay, so the difference between the maximum value and the minimum value is defined as the range. Okay, that is x max minus x min. This is the range. Okay, this is one of the measure of dispersion, which gives the date, which gives us about an insight how the data is spread, how much the variability in the data set. Okay, where also like we have variance is there. Okay, the same variance we have discussed in the previous classes. Like we have discussed na variance of a random variable x is expectation of x square minus expectation of x whole square. The logic is same, we have different formula only. Okay, uh, it is like it is 1 by capital N, which is summation FIA. Okay, summation of FI xi minus x bar whole square. This is the formula to calculate the variance. Okay, and the standard deviation is also there, which is in like standard deviation. It is defined as like positive under root of variance. Okay, this is called the standard deviation. We also like use coefficient of variation. Okay, so coefficient of variation can be calculated like HD by mean into 100. You may like multiply 100. When we multiply with 100, then it is in percentage, and when we not multiply this with 100, then it is in like probability format. Okay, lie between 0 to 1 something. Okay, even more than 0 to 1 is also there, but in general. Okay, so coefficient of variation SD by mean, standard deviation divided by the mean value and multiplied by 100. Okay, so this is how we calculate the measure of dispersion, how the data is scattered. This can be measured with the help of these different dispersion measures. Okay, we also have third point. Okay, like measure of skewness. Okay, so measure of skewness. What is skewness? That it measures the asymmetricity presence in the data. Measures the asymmetricity in the data. Okay, so it measures the asymmetricity in the data. So that means like we have different kinds of asymmetricity. Okay, so those can be let me write in plot a graph actually. From there we are like able to calculate have an image about the asymmetricity. Okay, so okay. This one is one graph. This is another graph, and let me. Okay, so we have three different like possibilities of the graph. Okay, plots. Okay, so these plots, just imagine here in the first plot, this is kind of like symmetrical. Okay, it is kind of symmetrical. So this is a symmetric data or symmetric plot. Okay, the in the second plot, we can see that most of the data like lie within the first part of this graph. Okay, so this is actually positively skewed data. Okay, positively skewed actually. Okay, positively skewed plot, and in positively skewed, uh, here we have like observe mean is always greater than median is greater than mod. Okay, and also there is this one is negatively skewed data. Here in negatively skewed data, most of the data lie within the latter part or within the second half of the curve. Okay, so this is called like negatively skewed. Okay, so this is negatively skewed curve. Here in this case, mean is less than median is less than mod. This is in general true. Okay, not always, but in general, it we can see that the mean value is the minimum in the measure of central tendency when we are dealing with the negatively skewed data, and when we are dealing with the positively skewed type of data, then the mean value is always greater than the other two central tendencies like median and mod. Okay, so uh, this is like the asymmetry. This is how we measure the asymmetricity present in the data. Also, we have a measure coefficient of symmetricity. Okay, we have coefficient of skewness actually is there. That is beta one. Okay, coefficient of skewness is there. That is beta one. Uh, okay, beta one, which is defined as like mu3 square upon mu2 cube. Mu3 and mu2 is nothing but the central moments. Mu3 is the third order central moment. Mu2 is the second order central moment. Okay. And also there is one more alternative, which is gamma 1. Uh, that is nothing but the positive under root of beta 1. Okay. We can use either beta 1 or we can use either gamma 1. In some papers, sir have actually uh, like mentioned these things like taking under root. Okay, so anything, the logic is same. Okay, the formula is different, but the logic is same. Okay, either we can use beta 1 or we can use gamma 1 to measure the asymmetricity present in the data. So for the symmetric data, the beta 1 is actually, let me write it here as a gamma 1. Okay, the gamma 1 actually is 0. Okay, if gamma 1 is 0, then those data is asymmetric in nature. Okay, and for the positively skewed, gamma 1 is positive actually. Okay, and for the negatively skewed, like gamma 1 is negative. Okay, so this is how like the we are able to uh, check the presence of asymmetricity in a data set. Okay, so we have like up to this point like uh, we have like learned about the measure of central tendency in which mean median mod is there, measure of dispersion in which like range, standard deviation, variance is there. Okay, then measure of skewness is there. Okay, so in which we have discussed about the asymmetricity of the curve. There are three kinds of curve, either positively skewed, either negatively skewed, or symmetric. And how to calculate the coefficient of skewness, we have also mentioned here as a coefficient of skewness as beta 1 or gamma 1. Okay. Now there is one more, that is measure of symmetry, kurtosis. Okay, the last one, measure of kurtosis. Okay, so measure of kurtosis is also there. Okay, so let me plot one graph again. Okay, now okay, one curve is this. One curve is actually, it should not touch the ground, but pardon me for this. Okay. Okay, and there is one different, one more kind of curve. Let me write with this color. Okay, so like I have like drawn three different kinds of curve, and this curve is on the basis of the height or peakedness. Okay, so if you see, you will find it measures the peakedness or flatness of the curve. Okay, so measure of kurtosis measures the peakness or flatness present in the data set. Okay, so there are mainly three kinds of kurtosis data is there. The this one, okay, and this one and this one. Okay, the flat one, the which is in most flat, is called platychotic. Platychotic. Okay, the mid one, which is also termed as like normal one, so it is called mesochotic, or some people call it normal curve also. And the peaked one, the one which is the highest peaked, is called like leptochotic. Okay, so there are three kinds of data on data set on the basis of like peakedness or flatness. Either the data set may be platychotic in nature, or it may be in mesochotic in nature, or it may be in leptochotic in nature. Again, we have like coefficients of kurtosis is there, which is beta 2, which is mu 4 upon mu 2 square. Again, mu 4 is the fourth order central moment, and mu 2 square. Mu 2 is nothing but the second order central moment, which is variance, and mu 2 square is square of variance. Okay, and similarly, the gamma is coefficient is also there. Both are similar actually. So it is defined as beta 2 minus 3. Okay, so for the leptochotic curve, the value of gamma 2 is greater than 0. For the platychotic curve, the value of gamma 2 is less than 0. And for the mesochotic curve, the value of gamma 2 is equal to 0. Or we can say that the value of beta 2 is greater than 3. The value of beta 2 is equal to 3. And for the platychotic, the value of beta 2 is less than 3. Okay, so these are their usual meaning. Okay, so on the basis of the measures of kurtosis, we can define whether the data set is leptochotic in nature, mesochotic in nature, or platychotic in nature. Okay, so this is all we have discussed in descriptive statistics. Okay, how the data is where the data is centrally tended, how much the dispersion in the data set, and what are the asymmetricity present, and how the peakness or flatness presence in the data set. These are the four topics we need to know for a data set. Okay, so this is how we will discuss about the descriptive statistics. Okay, we have also one more option to check or to have some knowledge about the data set. That is nothing but the graphical presentation. Okay, sir has already mentioned all these topics in his lecture, so I highly recommend you people go through there. There is like more detailed format. I'm just taking recap. Okay, so like there are graphical presentation is also there for the. Okay, so we have bar charts. Okay, you people already know about the bar chart or bar plot or bar graph is there. Whatever, let me write it bar plot. Okay, bar plot is there like in that this manner. So these are the bars. Okay, these are the rectangular bars, and here on the x-axis we have categorical data. Okay, these are the categories like A, B, C, D, and E. Suppose the export of India, like how much amount of like petroleum or oil India has export or India will export in 2025. Okay, so India, and there are 5 countries. Okay, so there are different countries and the amount of oil they have export or import some other goods. Okay, so these are the categorical in nature. So we use bar plot to represent these kinds of data. Okay, in which x-axis represent the categories and y-axis define the number or the amount of belonging to all those categories. Okay, so it is mainly used to represent the categorical data. Also, like we have histogram. Histograms is there. Histogram is like kind of bar chart, but it is mainly used to represent the continuous data. Okay, histogram only can be formed for the continuous type of data. Okay, or it is like okay, let me write. It is mainly used to represent the continuous form of data. Also, this histogram shows the distribution of the data, like how the data is distributed. That is, let me write that, let me plot the histogram and then we will discuss. Like it shows the distribution of data. Everyone know about like how the histogram is look like. Okay, so suppose we have like, suppose these are the histograms. Okay, this is like suppose 10, 20, 30, 40, 50, 60, 70, 80, 90 Z and so on. Okay, so here we have xi values, and on the x-axis, sorry, on the y-axis we have frequency. Okay, so we plot the graph for the continuous type of data. Here you can see if we see that like if you focus on the red curve, actually you will find that like you will find out this data is more than half of the data lie within the first half actually. Okay, if on the basis of position, if we define, then we will find that most of the data lie within the first half. So this implies this is actually a positively skewed kind of data. Okay, so that means it gives us the distribution of data, how the data is distributed, like it is either positively skewed, it is either negatively skewed, or it is maybe symmetrical in nature. Okay, so this can be find out with the help of the histogram. Okay, also with the help of those histograms, suppose let me write another one. Suppose I'm just drawing roughly. Sorry. Okay, suppose this kind of data is there. Okay, then the value, suppose we take the mid value. Okay, and drawing these cross points, when we drawing these cross point with the straight line, and the two cross points like this, then this, the blue curve is defined as the frequency polygon. Okay, it is like a polygon, na? Because there are more than, there are more sides, and the base is the x-axis. So it is a frequency polygon. Okay, frequency polygon. Okay, if we like we connect these cross lines with a freehand curve, then it is a frequency curve. Okay, if we connect these cross section, these cross points with a straight line, then it is a frequency polygon. And when we connect these cross points with a freehand curve, then this curve is known as frequency curve. Okay, so these are the different kinds of data. With the help of those, we are a different kind of measures actually, or graphical present representation. With the help of those, we are able to infer about the data, the distribution of the data, the how the data is distributed. Okay, we have inference regarding the data with the help of these curves or plots. There is also pie chart is there. Okay, you people know about the pie chart. It is actually a circular chart. Na? Suppose let me draw a circular chart. Okay, suppose it is a circle and we have different sectors is there. Suppose we have make four sectors actually. Okay, so there are four sectors sector A, B, C, and D, and this the area of sector represents the sorry, this area of sector represents the frequency is directly proportional to the frequency or the amount of belonging to A, B, C, or D. Okay, so this is how pie chart works. Okay, the whole angle is 360, and the bigger the sectorial area, the more the amount or the more the frequency related to that particular category. So this is pie chart. It is circular in nature. Okay, and then we have also box and whisker plot is there. It is clear, na? Is it? Can anyone confirm it is visible and audible and everything is clear?
Yes, sir. Everything is clear.
Okay, thank you. Box and whisker plots. Okay, this box and whisker plot is also there. This plot is used mainly for the data distribution. This represents the data distribution, and it is mainly based on 5-point summary or 5-point statistic summary. We have used 5-point statistic summary. These points, the 5 points are actually the minimum value of the data, the first quartile, that is Q1, the median is there, the third quartile Q3, and the maximum value. Okay, so this is when we have these 5 points, then we are able to plot the box and whisker plots. This box and whisker plot is mainly used for the detecting outliers, okay, to detecting the outliers present in the data set, and also to compare two data sets or more than two data sets together. Okay, so if there is outlier, then we use box and whisker plot to visually find out whether that particular data uh, is that data point is a outlier in that data set or not. Okay, let me write just plot some graph, and it is, I think, visible. Okay, these are the possibilities. I'm just trying to create an image how it is used to detect the outliers and comparing the distributions. Okay, so like in the first, this is actually, okay, let me use another color. So suppose this is actually minimum value of the data set. This point is called the first quartile. This point is called the third quartile. This point is called the maximum. And in a similarly, okay, we can like find out these are the points for the minimum and maximum and the first and third quartile. This is Q1, this is Q3. Okay. Again, there is one more point is missing, the median value. Okay. And the box contains the median value actually. So it may possible sometimes the median value lie here. Okay. It may possible that the median value lie here, and it also may possible that the median value lie here. Okay. So there are three possibilities actually where the median values lie in the same, suppose here. Okay, so in the first plot, the median value, suppose this is let me write the m1, m2, m3. This is for the comparison purpose actually. Okay, there is only either m1, either m2, or m3 is there in the box, but for the comparison purpose I have like plot the three. Okay, suppose there is only m1, not m2 and m3. So in that case, the median value is like quite near to the first quartile as compared to the third quartile. Again, if we have considered the m3 as a median and like remove m1 and m2 points or lines, then we have found out the median value is nearer to the third quartile and away from the first quartile. Okay, so this is like gives the distribution of data. Okay, how the data is like distributed. Okay, and we have different box and whisker plot. So with the help of these box and whisker plot, we can find where the positions of median and the first quartile and positions of median and the third quartile. It may possible also the difference between the minimum value and the Q1 and the Q3 and the maximum value gives whether the data is positively skewed or negatively skewed. Just like, for example, uh, sorry. Okay. For example, in the second, okay, in the second plot, if we can see here, the Q1 and the minimum value is like near as compared to this. So that means the 25% of the data lie here. Okay, and 75 and this is also contain kind of 75%, 25% data. Okay, so there is a more variability in the last data. Okay, in the last part of data, the Q3 part and the maximum part contains the 25% of data having more variability as compared to the minimum value and the first quartile. So that means more of the data lie in the first half. So that means for the second plot, it is actually positively skewed plot. Okay, so we can like able to detect whether this is which type of plots. Also, there is 1.5 interquartile range rule to evaluate the outliers. Okay, that we are discussing in some other classes. Okay, so here with the help of the box and whisker plot, we are able to detect the outliers present in the data set. Also, we are able to compare the different kinds of data sets or different kinds of distributions. Okay, there are also more than ogive and less than ogive is there, but there is a lot of points actually, but I'm not going to discuss all the points. Okay, ogive or ogive, there are lots of name, but I can say that we have more than ogive and less than ogive. So there is, I'm just writing a kind of ogive. This point where the ogive cuts, this is called actually median points. So when we draw for the same data set, when we draw the more than ogive or ogive and the less than ogive, then the point of intersection is defined as the median point. Okay, and so on. So up to this point, we have discussed about the descriptive statistics uh, and the graphical presentation of the data sets. Okay, so up to this point, is there any questions? If not, let's discuss about the sum sampling distribution. Okay, so in sampling distributions, like suppose when we are discussing about let x1, x2 up to xn, then these are the random variables because we are writing it in capital letter form. So this is like by default we will treat it as random variables. And when we are discussing about the small letters, usually these are called random samples. Okay, so like when I'm saying ki, suppose we are discussing about the height of students in a class. Okay, then this x is height of students in class. Okay, so this is like random variable. And when I am writing x1, that means height of first student. For example, A1 is stand for first student. So that is a number, na? Suppose 163 centimeter. X2, height of second student. It may be 178 centimeter and so on. So this is random sample. We have sampled or we have collected some data from this from the class. And which type of data is that? The data is like height of the student. I'm not talking about the weight or income or some other backgrounds or some other statistics or statistical characteristics. I'm talking about the height only. So the random variable is height of the student, and the small x1 value is the first height of the first student, and that is a number actually. 163, 172. We have a data, we have a numbers only. So these are the random samples, and the capital one is the random variables. Okay. Also, we have like parameters and statistics is there. These all are discussed in the, like sir have already discussed in a very detailed form. Okay. So you please must watch those videos. Okay. Every time you watch, you will learn something new. Okay. So parameters is actually functions of population value. And there is statistics. I'm writing statistic, not statistics. Statistics is a subject that we are discussing. Okay. And statistic is actually functions, functions of uh, functions of sample values actually. Okay, like parameter, when we are discussing about the functions of population values, like population mean, population median, population variance, then those are the functions of population values. Okay, and when we are discussing about when we have collected samples and then calculate the mean, that is sample mean is there, sample variance is there, uh, sample median is there, then those are the statistic. Okay, sample mean is a statistic, but population mean is a parameter. Okay, it is a parameter. So these are like basic differences. There are a lot of differences and lot of things to know about the parameter and statistic, but it is just a layman language. What is the difference between the parameter and statistic? The first one is the population values. It is a function of population values actually, and the second one is the function of sample values. Okay. Now there are different kinds of distribution that are also called exact sampling distribution. There are three distributions mainly. Let me write it. The first one is the chi-square distribution. Okay, or chi-square statistics or chi-square distribution. We usually denote it as like suppose x follows chi-square. Okay, with n degree of freedom. There is a degree of freedom actually. Okay, so the PDF of the chi-square distribution is like this: 2 to the power minus n by 2, and it's gamma n by 2. Okay, and x to the power like n by 2 minus 1, and e to the power minus x by 2. Okay, and the support of x is like 0 to infinity. So this is the density function for the chi-square distribution with n degree of freedom. Okay, also like this x which follows the chi-square distribution with n degree of freedom, this is similar to like gamma distribution with n by 2 parameter and 1 by 2 parameter. Okay, both have the similar feature. Okay, so this is the chi-square distribution. Also like okay, let me write the expected value. The mean of the chi-square distribution is nothing but the degree of freedom itself only. Like here n is there, so the mean value is n. The variability of the chi-square distribution is like twice of the degree of freedom, that is 2n. And the third order moment is actually 8n, and the fourth order moment is here like 48n plus 12n square. Okay, so with the help of the first, second, third, and fourth order moment, we are able to evaluate the measure of skewness and measure of kurtosis. Like beta 1, beta 1 is like mu3 square upon mu2 cube, or if we are discussing about the gamma 1, this is under root of beta 1. So if we calculate the beta 1, okay, then the beta 1 will be like 8 by n, and the corresponding gamma 1 will be like under root of 8 by n, obviously. Okay, so it is always greater than 0 if you find out. So this implies it is always positively skewed. But if we see that the n is in denominator, and when we consider n to be sufficiently large, then in that case it converges to 0. So that means for large n it converges to equal to 0. The beta 1 is equal to 0 for large n, and then in that case it converges to the normal distribution. That means positively skewed converted to the symmetrical in nature. Okay, so from here we can like conclude this as well. Again, so the measure of kurtosis is mu4 upon mu2 square is there, and this comes out to be like 12 by n plus 3 if you are like solving. I'm not solving these things. And or the corresponding gamma 2 is actually 12 by n. Again, it is greater than 0 and it is greater than 3. And from the above curve that we have discussed in the previous slides, you find out it is actually leptokurtic in nature. Okay, again, when for large n it comes out to be 0, then again it converges to the mesocortic in nature. So overall we see that for large n this distribution converges to a normal distribution. Okay, so this is the chi-square distribution, and this is how we have calculated their expected value, their variance, the skewness, and the kurtosis. Okay, then the next one is like the students t distribution. Okay, if anyone have any doubt, please ask. Okay, I'm just recapitulate those things. Okay, am I audible now?
Yes, sir.
Okay, Suppose here x is a random variable which follows the t distribution with again with degree of freedom small n. Okay, then in that case the PDF of this is like gamma of n plus 1 by 2 and divided by square root of pi n and gamma of n by 2. Then it is 1 plus x square by n to the power minus of n plus 1 by 2. And here the value, the support of x is like minus infinity to infinity. Okay, so this is the student's t, this is the PDF of the student's t distribution. Okay, also like also suppose if x follows normal distribution with mean 0 and variance 1, that is x is a standard normal variate, and y follows the chi-square distribution with n degree of freedom that we have just discussed in the previous slide. Okay, y is a chi-square variate with n degree of freedom and x is a standard normal variate. Then a transformed variable t, which is defined as the x and the divided by the square root of y divided by its degree of freedom n. So this transformed random variable t is nothing but follows t distribution with n degree of freedom. So that means the t statistics or the t random variable is defined as the ratio of the standard normal variate divided by the under root of chi square variate divided by its degree of freedom. Okay, so this is also we found out how the t distribution or the t random variable is uh, also the expected value of the t random variable or the t distribution is like 0. Okay, the expected value of t distribution is 0 and the variability, the variance of the t distribution is like n upon n minus 2 for n is greater than 2 actually. Okay, because variability is always positive, and for when we take n equal to less than 2 then the variability comes out to be negative. So that's why we have considered for n is greater than 2, and the third order moment is also 0, and the fourth order moment, central moment I'm talking about, 3n square upon n minus 2 n minus 4. Here again n is greater than 4. Okay, so this is how we have calculated the first four central order moments. And with the help of these central order moments, the measure of skewness is there, which comes out to be 0, which means it is a symmetrical in nature. Okay. And the beta 2, the measure of kurtosis is there, which is actually after simplifying 6 upon n minus 4. Okay. And this is actually positive. Sorry. This is actually positive. This implies it is leptokurtic in nature. Okay, so it is kind of leptokurtic in nature, and when we consider n equal to quite large, it comes out, it tended to 0. So from leptokurtic to mesokurtic for large n. Okay, it converges from leptokurtic to mesokurtic in for large n. Okay, so this is the t distribution. Now the next one is like f distribution. Okay, f distribution, unlike t and chi-square distribution, they have only one degree of freedom, that is n. We have considered n here. You may consider mu, p, q, any value. Okay, but in f distribution, we have two degree of freedoms actually. Okay, so the PDF, suppose x follows the f distribution uh, with parameter or with degree of freedom m or n. Okay, for example, so in that case the PDF of this f distribution will be like gamma of m plus n divided by 2, and it is divided by gamma of m by 2, gamma of n by 2, then m upon n to the power m by 2, x to the power m by 2 minus 1, and 1 plus m upon n x to the power minus of m plus n divided by 2. This is the PDF of the f distribution. Okay. We can also define the f variate, the f distribution variate, like if y1, suppose y1 is a random variable which follows chi-square distribution with m degree of freedom, y2 is a random variable again which again follow chi-square distribution with n degree of freedom, then a transformed random variable x, which is defined as the y1 divided by m y, sorry, y2 divided by n. Okay, this follows f distribution with m and degree of freedom. So this is also how we uh, define the f variate. Okay, so here we find out the x or the f variate is nothing but the ratio of the two chi-square variate divided by their degree of freedom. Okay, so this is how the chi-square f distribution is defined. Also, again, like the expected value of x is like n upon n minus 2. The variance of the f variate is like twice of n square m plus n minus 2 divided by m n minus 2 whole square and n minus 4 for n is greater than 4 actually. Okay, so this is how we calculate the mean and variance of the f distribution. Okay, you can calculate the third and fourth order moment also, but it is like quite a tedious job to calculate those third and higher order moments. So let's omit this part. Okay, so these are the three distributions. Okay, we have some remarks actually. Let me write some remarks and then we will solve some questions. Like suppose x x is a random variable which follow f distribution with the degree of freedom m and n. Then the random variable 1 by x follows the same f distribution with the degree of freedom n and m. So just the degree of freedom reverse. Okay, if m and n is there, then the reciprocal follows the n and f, m and m. Okay, so this is the one of the property of the f distribution. Also, like suppose t is any random variable which follows t distribution with n degree of freedom. Okay, then in that case, the t square random variable, the random variable t square follows the f distribution with n with 1 and n degree of freedom. Okay, if t follows t distribution with n degree of freedom, then t square follows f distribution with 1 and n degree of freedom. Okay, also like if x follows normal distribution with mean mu and variance sigma square, then we already know that z is a transformed random variable which is x minus mu upon sigma. This is standardization of normal random variable which follows normal distribution again with mean 0 and variance 1, that is standard normal variate. Okay, then z square which is x minus mu by sigma whole square. This follows actually chi-square distribution with 1 degree of freedom. So that means the chi-square distribution is nothing but the square of the standard normal variate. The chi-square variate is square of the standard normal variate. Okay, so these are like some of the properties related to these T, F, and chi-square distributions. Okay. So up to this point, if anyone have any doubt, then please ask. Otherwise, we will solve some numericals onward. Anyone? Okay. So, okay, like let's write some questions. Just a simple question like suppose if x1, x2, x10 follows normal distribution with mean 0 and variance 1, then find the distribution of like summation I from 1 to 10 xi square. Okay, so just using the property, just I'm discussing the third point, third remark actually. Since like we are given, since xi follows normal with mean mu, sorry, not mu actually, it's 0, no? With mean 0 and variance 1. So this implies xi square follows actually chi square that we have discussed just now. If xi standard normal variate, xi square, chi square 1. Okay. Let me write it here actually, if not xi or x1 square, chi1 square. If x1 square plus x2 square is there, it follows chi square with 2 degree of freedom. So this implies summation over I from 1 to 10 xi square follows chi square distribution with 10 degree of freedom. Just simple with the help of the remark number 3. The square of the standard normal variate is chi square variate. Okay, and we have 10 standard normal variate, so it is chi square variate with 10 degree of freedom. We can write the PDF of the chi square variate with 10 degree of freedom in the above. We have discussed the general formula in the above slide. Okay, so now the next question. Like we are given the distribution of marks and the number of students. Like we are given the marks of students and their corresponding frequencies. We need to calculate the measure of central tendencies. Find the different measures of central tendencies. Okay, so this is the question. We are given data. The data will be like this. Let me write it in a. Okay, let me change the color. Marks is there like 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Okay, marks is there. The number of students is also there. Okay, the number of students will be like 8, 10, 14, 9, and 9. Okay, now we need to find the different measures of central tendency. That means we need to calculate mean, median, and mode actually. Okay, so let's start with the mean. Since we are a marks the as there, so the x size will be like the mid value of the class marks. So 0 to 10, that means 5 is there, 15, 25, 35, and 45. This is the class mark. Okay. Now we need to find the FIXI because the mean is defined as summation of FIXI and divided by summation of FI. I from 1 to 5, I from 1 to 5. So we need to find the FIXI. Here FI is actually number of students. So FI is this, XI we have already written. So FI into XI, that means 8 into 5, that is 40. 10 into 15, that is 150. 14 into 25, 14 into 25, that is 350. Okay. And then 9 into 35, it's 315 is there. And 45 into 9, that is 405. Okay, so this is the we are using the direct method, direct approach to calculate the mean because it is a simple number. Na? If we are dealing with the larger number, then we are making some assumption. So you use assume mean method or step deviation method to calculate the average value or the mean value. So we have now we need to add 550 is there, 1, 5, 5, 10, 14, 15, 116 is there, carry 1, and 3, 3, 6, 10, 11, 1, 12. So 1260 is there. Okay, so 1260. The summation is 1260, and the summation of FI is 8, 10, 14, 9, 9, 9 plus 9, 18, 18 plus 14, 32, it's 42, it's 50. Okay, so the total will be like 50 for the total number of students, and summation of FIXI is 100, sorry, 1260. So putting those value 1260 divided by 50 comes out to be 25.2. Okay, so the mean value is 25.2. Clear? Now for the median, for the median L, the formula for the median is L plus n by 2 minus f upon h, sorry, n by 2 minus c upon f into h. This is the formula. Now, first we need to find the median class, and for the median class, we need to find n by 2, which is 50 by 2, which is 25. So we will now check the cumulative frequency class. Since there is no cumulative frequency column, so first let's create one column. This is cumulative frequency. So it is like 8, 8 plus 10, that is 18. So 8 plus 10 plus 14, that is 32. So 8 plus 10 plus 14 plus 9 equal to 41. And the last one is like 50. Okay. So here the in cumulative frequency, we find the value 25 or just above the 25. So here, if you see, you may find the value is this. So that means this class is our median class. Okay, so that means median class is 20 to 30. So that means what? L equal to 20. Okay, n by 2 is already we have calculated 25. C is the cumulative frequency just preceding the median class. So that means the value of C is 18 actually, because the cumulative frequency of the median class is 32 and just above the median class is 18. So the value of C is 18. The F is the frequency of the median class. The frequency of the median class is 14 here, and the value of h is actually 10. So just putting those values in the formula. So median is like 20 plus n by 2 is like 25 minus 18 upon 14 into 10. This comes out to be 20 plus it's 7 upon 40 into 10. So it is like 20 plus 5. So the value of median is 25. Okay, simply we are able to calculate. Now the value of mod. Again, we need to first find the model class. Okay, let me change the color again. Now mod. The formula for mod is like L plus F1 minus F naught upon twice of F1 minus F naught minus F2 into H. Now the model class is like we can like find the model class with the help of the highest frequent uh, class group, the class interval. So here, if you see, you will find the 14 is the highest number actually. If you find in the students frequency column, the highest number is 14, and that also belongs to the same class as the median. But it may possible it belongs to some other class interval. But for here, for this particular example, the model class is again 2030. So the model class is 20 to 30 group. Okay, now the L is 20. The F1 is the frequency of the model class, that is 14. The F naught is the frequency of the mod of the class just preceding the model class, 10. And F2 is the frequency of the class just succeeding the model class, and that is 9 actually. If you can see, that is 9. And the value of H is 10 here. So we have all the information. Now the mod is 20 plus F1 14 minus F naught 10 upon twice of F1, that is 28, minus F naught, that is 10, minus F2, that is 9, into H, that is 10. So this implies 20 plus it is 4 upon 28 minus 10 minus 9 comes out to be 9 divided by 10. Okay. So like 4 by 10. Actually, if it's 20 plus 4 into 1.11 and so on. Okay. So it is like 20 plus 4.44. So the mod value is nothing but 24.44. Okay. So the mod value is 24.44. Okay. So we have calculated the mean value, we have calculated the median value, and we have also calculated the mod value for the group frequency distribution. Also, if you people remember, we have discussed one empirical relationship between the mean, median, mod. Okay, alternative approach to calculate the mod value. Okay, just let's see what we like. What is the mod value? Okay, so like we have na 3 median equal to twice of mean plus mod. Okay, this is the empirical relation between the mean, median, and mod. So we have calculated the median value. So it is 3 into the median value we have calculated is 25 actually. And the mean value is twice of the mean value is 25.2. And the mod value, suppose we don't have the mod value. Okay. So now 3 into 25, it's 75 equal to it's 50.4 plus the mod value. And then mod is actually 75 minus 50.4. This comes out to be like 24.6. Okay, this is the mod value. So if we are using the formula, then 24.44 the model value comes out to be. And when we use the empirical method, then empirical relation between the mean, median, and mod, the mod value comes out to be 24.6, which is like quite close to each other. So this is how we are able to calculate the measure of central tendencies. Okay. Any question up to this point?
No, sir.
Okay. Okay, now we have different questions like we are given the mean marks. We have questions like the mean marks. Okay, The mean marks in statistics of 100 students in a class were 72. Okay, the mean marks of 100 students in a class were 72. Also, the mean marks of boys. Okay, the mean marks of boys are 75, and their number, and the number of boys, that is, and their number is 70. So find the mean marks of the girls. Okay, so we are given like in a class of 100 students in which 70 are boys and 70, 100 minus 70, that means the rest are girls. Okay, the overall the mean value is 72, and for the boys only the mean value is 75. We need to find the mean values, the mean marks for girls only. Okay, so like here the number of boys we are given here is actually 70. Okay, and the number of girls here is, it is actually 100 minus 70 because there are 100 students in total. So it is 30 students is there. Okay. Also, we are given, suppose we can write for the simplicity purpose so that we can use the direct. Suppose we can write it N1, it is N2 is there. The mean marks for boys we are given. The mean marks for boys is 75. Let's call it X1 bar, for example. Okay, we need to, and also we are given the total mean. Yeah, the overall mean. Uh, Overall mean will be like 70 is there. No? Sorry, 722 is there actually. The overall mean is 72. Let's write it X bar because it is overall, so it is X bar. Now we need to find the mean marks of girls. So let the mean marks of girls be, suppose for example x2 bar, for the simplicity purpose we have considered the mean marks for the girls is x2 bar. So we have a combined mean formula. So using the combined mean formula, we have different categories or sectional mean are there actually. So that is n1 x1 bar plus n2 x2 bar, because there are two groups here only. So n1 plus n2 is the overall mean. The overall mean x bar is n1 into x1 bar plus n2 into x2 bar divided by n1 plus n2. If there are three, then n3 and x3 bar, and in denominator x3 is also added, and so on. So putting those values, so the x bar is like, sorry, the n1 is there. So n1 is like 70 into x bar, x1 bar is like 75 plus n2 is actually there 30, and x2 bar is not known, and divided by n1 plus n2, that is also actually 100 here, and x bar is actually 72. Okay, the overall mean is 72 is already given. The overall mean is 72. Okay, now it's a simple question. It's 30, x2 bar is like 72 into 100 divided by 70 into 75. So x2 bar is actually, if you can solve, 7200. Okay, sorry. We have make one mistake actually here. Why should I? It's minus, na, because it is here plus, na. 7075, sorry, 70 into 75. 70 into 75. So that is x2 bar is equal to 7022 minus 7075 is 5250. Okay, and whole divided by and the whole divided by 30. Okay, so it's simple actually. If you solve, and you will find it's 65 actually. So the average marks for girls in the class is 65. Okay, so this is how we solve. Also, like we have a question, like suppose if the random variable x follows the f distribution with the degree of freedom 3 and 7. Okay, find the value of expected value of x into expected value of 1 by x. Okay, this is a simple question. Okay, we are given the distribution of the random variable x, which is f distribution with the parameter or with the degree of freedom 3 and 7. We need to find the expected value of x into expected value of 1 by x. Okay, so since we know that we have already discussed actually in the previous slide, we have already discussed like if x follows f distribution with parameter m and n, then 1 by x follows the same f distribution with parameter n and m. Okay, so that means here the value of m is actually uh, okay, let me write in general form first. So expected value of x is what? Expected value of x is actually if x follows f mn, then the expected value of x is n upon n minus 2. Okay, and if expected value of 1 by x we are discussing, it is nothing but m upon m minus 2. Okay, this is the general formula. Okay, now since m equal to, we are given m equal to 3 and n equal to 7, m equal to 3 and n equal to 7. So expected value of x is 7 upon 7 minus 2, that is 7 by 5. Okay, and expected value of 1 by x, m, that is 3 upon 3 minus 2, not 1, that is 3. So we need to calculate expected value of x into expected value of 1 by x, that is 7 by 5 into 3 comes out to be 21 by 5, or if you simplify in the decimal format, it is 4.2. Is it clear? Hello? Is there anyone?
Yes, sir.
Is it clear up to this point?
Yes, sir.
Okay, we have one more question. Okay, the question is let x1, x2, dot xn. These are IID random variable which follows a normal distribution with mean mu and variance sigma square. Okay, where mu and sigma square both are unknown. Okay, now we define some variable. Now we define x bar n minus 2, that is n minus 2 only. So it is 1 upon n minus 2 summation I from 1 to n xi. Okay, so it is a actually sample mean up to with sample size n minus 2 actually. Okay. We also define some statistic. That T1 statistic is defined, that is 1 upon n minus 3 summation uh, I from 1 to n minus 2, and it is xi minus x bar of n minus 2 whole square. Okay. Also, we define another statistic. Okay. I am telling statistic. That means it is a functions of sample values. Okay. In general, I am using like capital, like capital Xi, but actually it is a sample values. So please keep it in mind. So now x2 is there like x n minus 1 minus of xn, and it's divided by root 2. Okay. And it is defined for n equal to 3. Okay. So we have defined these three. Okay. We have IID random variable, which follows the normal distribution with mean mu and variance sigma square. We define x n minus 2 bar, which is 1 upon n minus 2 summation of I from 1 to n minus 2 is actually, okay, summation xi. Now we also define one statistic T1, which is 1 upon n minus 3 summation over I from 1 to n minus 2 xi minus x n minus 2 bar ka whole square. Okay. And the another statistic T2, which is xn minus 1 minus xn divided by root 2 for n is greater than 3. Okay. Now our aim is to find the distribution of T2 divided by under root of T1. Okay. So let's start with the properties or with those concepts that we have discussed today. Okay. So here we are given like, let me change the color. Okay. Here like it is given T1 is like 1 upon n minus 3 summation I from 1 to n minus 2 xi minus x n minus 2 bar whole square. Okay. So we can write like this. If you can find, it is n minus 3 T1 equal to summation I from 1 to n minus 2 is there, is xi minus x bar n minus 2 whole square is there. Okay. Uh, what if like we divide sigma square? We divide the both side by sigma square. So it is like kind of this, na? N minus 3 divided by sigma square T1 equals summation I from 1 to n minus 2. It is xi minus x bar n minus 2 sigma square. So sigma and square is there. Okay. So this is now actually, if you find, you will find out it is nothing but chi square and degree of freedom. Okay. So here n equal to n minus 3. So this follows chi square with n minus 1 degree of sorry n minus 3 na? N minus 3 degree of freedom. Okay, so we have the distribution of n minus 3 upon sigma square T1, which is nothing but the chi square distribution with n minus 3 degree of freedom. Okay, again, uh, we have T1. Okay, now on T2, like let me write here only, change the color. Okay, like now we have T2. We have defined the T2 as like x n minus 1 minus xn divided by root 2. Okay. So from here only, root 2 times of T2 is actually xn minus 1 minus xn. Okay. And since we are given, if you can see, we are given x1, x2, and xn. These are all IID random variable and follows the normal distribution with mean mu and variance sigma square. So that means xn and xn minus 1 also follows the normal distribution with the same parameter. Okay. And we people know, like, let me write some in note form. Let me write in note form actually. Like if like y1 and y2 like are IID normal with mean mu and variance, sorry, not mu1, it's mu actually, mean mu and variance sigma square, then in that case y1 minus y2, this follows normal with mean mu minus mu. That means zero actually. If you find out, you'll find zero, and sigma square plus sigma square. Okay, let me write in some more formal time wording. Okay, and it is sigma square plus sigma square. The variance is always in like summation format. Doesn't matter it is minus or plus. It always adds on. Okay, so this means it is like normal with 0 and 2 sigma square. So it is like a note using the same logic in the above. So we will find uh, root 2t root 2 t2 equal to xn minus 1 minus xn. This again, if you find out like xn minus 1 minus xn, this again follows normal with mean 0 and variance 2 sigma square from the above because it follows like linearity property. Now we have these two things. Now one more thing, like we know that, okay, like we know that if x follows normal distribution with mean 0 and variance 1 and y follows chi-square distribution with degree of freedom n, then we have defined in property like the x divided by the under root of y divided by root n, this must follows t distribution with n degree of freedom that we have discussed in the remarks section in the above slides. Okay, so that means okay, so that means what, x and this, so the upper one is like standard normal variate and the y divided by its degree of freedom and taking the positive square root, it is chi-square. So that means here we have like if you remember, sorry, here like root 2 t2, it's capital T2, root 2 t2, that is here only. Okay, it is normally distributed. Okay, it follows normal distribution with 0 and 2 sigma square. Okay, so let's standardize this. So this implies what, root 2 t2 minus 0 and divided by like 2 sigma square, root 2 sigma square. This follows normal distribution with parameter 0, 1. So just simplifying, we will get like T2 divided by sigma. This follows the normal distribution with mean 0 and variance 1. Okay, so T2 by sigma follows standard normal variate. Also, also like we have n minus 3 upon sigma square T1. If you can see here, we have this one, n minus 3 t1 upon sigma square. It follows chi square with n minus 3 degree of freedom. So this follows like chi square with n minus 3 degree of freedom. Okay, so like so like t2 divided by sigma and whole divided by n minus 3 t1 divided by sigma square And this particular quantity is divided by its degree of freedom, that is also n minus 3. Okay, so the upper one is the actually normally distribution, no, standard normal distribution. T2 by sigma, it is standard normal distribution, and the second one is n minus 3 divided by sigma square into T1. It is chi-square distribution with n minus 2 degree, n minus 3 degree of freedom. So this quantity gives actually T distribution with n minus 3 degree of freedom. Okay, so just simplifying these quantity, we will find, I'm not going to simplifying step by step, just after simplifying sigma is square, sigma is there, cancel out, n minus 3, n minus 3 is cancel out. So it is actually T2 upon root of T1. Okay, this follows T distribution with n minus 3 degree of freedom. So this is our answer. The question is like we need to find the distribution of T2 divided by under root of T1, and this follows the T distribution with the degree of freedom n minus 3. Okay, like is it clear na? Hello, is there anyone?
Yes, sir.
Okay, okay. Now there is one more question actually. Also like suppose let's add one question in the continuity form. Also find the like distribution of, suppose I'm saying T2 is square upon T1. Okay, also we need to find the distribution of this as well. So how to find out? So again, like we know that here x, like if we have like okay, let me write it in different color for you. Since we know that na, since if x follows like chi-square distribution with m degree of freedom, and y follows the chi-square degree with n degree of freedom, then x divided by m whole divided by y divided by n, this quantity follows the f distribution with mn degree of freedom. Okay, that we have already discussed. Okay, so now like here T2 divided by sigma, that we have already defined, see that it follows the standard normal distribution. So we have also discussed that the T2 divided by sigma whole square, like the square of the standard normal variate follows the chi-square distribution with 1 degree of freedom, that we have already discussed in the remark section. Also, we have n minus 3 upon sigma square T1. This follows chi-square degree with n minus 3 degree, sorry, chi-square distribution with n minus 3 degree of freedom. So we have two different chi-square distribution with their degree of freedoms. So again, it's T2 square divided by sigma square. It is divided by its degree of freedom, since its degree of freedom is 1. So I'm divided it by 1. Now again, n minus 3 T1 upon sigma square, it is divided by its degree of freedom, that is n minus 3. Okay, so this must follows actually f distribution with 1 degree of freedom and n minus 3 with n, sorry, 1 and n minus 3 degree of freedom. And when we simplify the left hand side part, you will find that it's T2 square divided by T1 actually, and this follows the f distribution with 1 and n minus 3 degree of freedom. So that means the distribution of this part is like this. Okay, so is it, I think, is it okay na, to understand how we have calculated different kinds of distributions? Hello.
Yes, sir.
Okay, okay. So I hope we people have understand how the exact sampling distribution or the TF and chi-square sampling distribution is used, how the descriptive statistics is used, how we have already discussed a lot of properties, lot of concepts, related to the descriptive statistics and the sampling distribution as well. We have also like trying to cover the examples related to these topics. Okay, so if you people have any doubts regarding any point, anything, so you people may ask. You may ask here, or you may ask in on the YouTube channel as well. You people have already provided the link by the NPTEL, or any way with the help of my LinkedIn profile or my website or anything. Okay, from anywhere you have any doubt, you people are like may ask any questions. Okay, related to these topics. And if there is no question, let's conclude our session here. So I hope there is no question. So let me first stop the recording